We use the internet every single day, and honestly, it kind of feels like magic, right? But what if I told you that magic is actually a massive global network of undersea cables, digital traffic cops, and a system so interconnected it's basically a planetary brain? Today, we're going to pull back the curtain and see how the internet really works. I absolutely love this quote because it just cuts right through the noise. We have this idea of the internet as some kind of, I don't know, ethereal cloud, but the reality, it's way more grounded. And honestly, it's way more impressive. It's a physical thing, and getting that is the first step to seeing the sheer genius behind the magic we take for granted. So let's do this. Let's demystify the whole thing. We're going to follow one single click on its absolutely wild journey, from your fingertips across the entire globe and back to your screen, all in like the blink of an eye. Okay, so our little journey here has four main pit stops. We're going to start with the physical stuff, the hardware. We're talking actual cables and servers. Then we'll get into the protocol suite, which is basically the digital rules of the road. After that, we'll explore the web and how your browser actually finds anything. And finally, we'll land on the front end, which is the pretty web page you see on your screen. That's our roadmap. Let's get into it. All right, first stop, we're getting physical. I mean, the part of the internet you could actually go out and touch. We're diving deep, literally, into the submarine superhighway. This is where your data's journey really begins. So the second you click on something, anything, your data starts a very real physical journey. It shoots from your computer or phone through your Wi-Fi router and out to your internet service provider, your Comcast or Verizon. And that's the moment your little request gets launched into this gigantic worldwide network. And get this, a massive part of that network looks exactly like this. Thousands upon thousands of miles of fiber optic cables just sitting on the ocean floor, physically wiring up the continents. So when you're watching a video hosted on a server somewhere in Europe, your data is literally screaming across the Atlantic Ocean inside one of these cables at almost the speed of light. I mean, that's just wild, right? Okay, so having this massive global highway is awesome, but you can imagine without any traffic rules, it would just be complete and utter chaos. And that brings us to layer two, the rules of the digital road. Well, that's where something called a protocol suite comes in. It's basically the shared language, the official rulebook that every single connected device has agreed to use. It's what makes sure your data gets from point A to point B without getting all scrambled or lost along the way. Now, two of the big players in this rulebook are TCP and IP. Just imagine them as the ultimate digital shipping department. First up, you've got TCP, the Transmission Control Protocol. Think of it as the meticulous organizer. It takes your data, say a photo, and chops it up into tiny numbered packets. Then IP, the Internet Protocol, jumps in. It's the mail carrier. It slaps a destination address on every single one of those packets. And then, when the packets all arrive, TCP's job is to do a head count, make sure they're all there, and put them back together in the exact right order. It's a brilliant system. So our little data packets have an address stamped on them. But wait a second, there's a problem. Your computer only understands numbers, but you just typed in a name. How does it know the right numerical address for a website? Well, that brings us to the internet's giant address book. And this is the big question, right? Your computer needs a precise string of numbers, like an IP address, to find anything. But we humans, we remember names, like theexplainer.com. There has to be a translator in the middle. So, how does that happen? The answer is something called DNS, the Domain Name System. It is a massive, global, and totally decentralized directory. And its main job, its whole reason for being, is to translate the website names we type into the IP addresses computers actually need. And that address book analogy is perfect. It really is that simple. You look up a name you know, and the DNS tells your computer the number it needs to call. Without this, the web would be basically unusable. We'd all be walking around with notebooks full of numbers just to check our email. No thank you. Okay, so let's recap. Our request zipped across the ocean, it found the right server thanks to the DNS. And now that server is sending all the data back to us. We're at the final stage, how this all comes together to form the web page you actually see. Here's a fun fact. The server doesn't send you a finished picture of the website. Nope, it sends you a flat pack furniture kit, basically. HTML, that's the wood and the screws, the basic structure and the text. CSS is the paint, the fabric, the design. It's everything that makes it look good. And then you have JavaScript.
That's the cool stuff. The hinges, the sliding drawers, all the interactive features. Your web browser is the assembly line that takes these three types of code and builds the final product instantly.
You know, when you step back and look at it, this whole system is just an absolute marvel of engineering, doing this dance billions of times a day. But because it's so incredibly complex, it's not foolproof. Sometimes this global brain, well, it glitches. So what happens when the journey goes wrong?
Well, failures can be passive, something like packet loss. That's literally when a few of those little data packets we talked about just get lost in the mail. That's why a website might load super slow or an image might look broken. But they can also be way more sinister, like an SQL injection. This is where an attacker doesn't send a normal request. They send a malicious command disguised as one. If the website security isn't up to snuff, it might just run that command and accidentally hand over a bunch of private data. It's like slipping a fake order into the mail system to rob the warehouse.
So let's bring it all home. From that one simple click, a journey through cables under the ocean, guided by digital rules and a global address book, all reassembled on your screen in milliseconds. It happens billions and billions of times a day. And while it feels like magic, now you know it is one of the greatest feats of engineering humanity has ever pulled off. And that leaves us with one last massive question to think about. This global brain, it connects more and more of our world every single second. But as we become more and more reliant on it, you have to ask yourself, are we building a modern marvel that's going to elevate us all? Or are we just creating the world's biggest, most fragile single point of failure? Something to chew on.